info person, this is Anton, and in this video we're going to be discussing a somewhat unusual convergence between science fiction and reality. And specifically, we're going to discuss something referred to as the Project Hail Mary, which is of course a recently released movie starring Ryan Gosling that's based on a 2021 novel by Andy Weir. And many of you might be already familiar with this because this is a pretty famous novel and is now going to be a pretty famous movie as well. But while here the story follows a science teacher trying to save Earth from sun-eating microbes, it has now also served as a major inspiration for a real scientific study that has recently been published and that as always you can find in the description below. And so here in a study led by researchers from the Carl Sagan Institute at Cornell, scientists identified some of the best places in the universe, or I guess technically in the local neighborhood of our own galaxy, where in theory we should be looking for life and where technically we could maybe find it. But in a nutshell, the study itself was very simple. Here the researchers analyzed over 6,000 different exoplanets discovered and confirmed so far, in order to narrow down the most likely planets to basically be habitable, or essentially to find the ones that may contain the highest chance for some kind of life. And out of over 6,000 planets, so far they've actually identified 45. And to be more exact, 45 Earth-like worlds we should be focusing on. And here this is actually kind of important because, just like the movie and the novel suggest, life might be much more versatile than we currently imagine and could thus exist in a lot of extreme conditions. But I guess the question is, so how do we actually choose these worlds? And why these specific 45 planets? Well, here the idea was really simple, trying to find planets that seem to be Earth-sized and seem to be situated within the so-called habitable zone or the Goldilocks zone. Basically, the areas where the conditions are just right for maybe some kind of a liquid water to exist. Planets that are not too hot and not too cold. But the Cornell study actually goes a little bit further. Here, they categorize these 45 planets based on how similar their radiation levels seem to be compared to modern Earth. In other words, it's not just about liquid water, it's also about the amount of total energy received. And out of these 45 candidates, quite a few of them have been discussed before in some of the videos you can find in the description. For example, the closest one to us, Proxima b. This is literally the closest planet to us and turns out to be in the habitable zone of the host star. Although in this case the star is obviously a little bit different because this is a red dwarf. But since this planet is extremely similar to Earth in terms of mass and in terms of size, and because it's in the habitable zone of Proxima Centauri, here it's believed to be an extremely interesting object. But there's one major problem with this planet. Based on the perspective from planet Earth, we unfortunately cannot see it pass in front of the star, and so trying to study its atmosphere, or basically learn anything about it right now, is kind of difficult. We only know of its existence because it pulls on the star just a little bit, and so here we can see the wobbling of the star as a result of the planetary orbit. But apart from Proxima Centauri, there are also the TRAPPIST-1 system planets, many of which also meet the requirements for the possibility of life, and specifically TRAPPIST-1e. And that's the one that NASA has not studied well yet, mostly because it's just a little bit smaller and a little bit more difficult to detect its atmosphere. But we also have this object referred to as TOIS 715b, discovered in the system of TOIS 715. This is a little bit farther away at 140 light years away from us. But back in 2023, it was confirmed to have a very interesting habitable zone super-Earth that has an extremely high chance for the existence of liquid water. And so here we have three separate systems that are close enough and exciting enough to possibly host alien life, assuming it exists. But right now, none of the telescopes have been able to confirm anything yet, or study their atmospheres in detail. So we actually have no idea what's going on here. But importantly, all of these planets seem to receive very similar levels of stellar energy compared to planet Earth, which is of course why they're highlighted in this study. And so the study led by Professor Lisa Kaltenegger utilized the data from the Gaia Space Telescope that provided precise measurements for every star, and the data from NASA Exoplanet Archive, which authored a comprehensive database of all known planets, with the main emphasis being that Earth-like does not mean Earth identical. Or basically here, they're not looking for the exact copy of planet Earth with exactly same habitable conditions, but instead for a planet that, though different, potentially has extremely similar chances for creating its own version of life. For example, planets orbiting redder stars or red dwarfs might have different types of flora that reflect colors other than green. Or basically have plants that are not green, but are entirely different because they seem to have different types of photosynthesis. Or maybe they have the idea known as biofluorescence, basically planets orbiting stars with very high UV radiation, such as various F-type stars. Here, some organisms might actually evolve to reflect a lot of this, and might have evolved to glow or to exhibit biofluorescence as an important protective mechanism. And this is something we do find on Earth occasionally, especially in some more extreme organisms. But at the same time, researchers behind the study highlight that if we only look for life exactly like the life from Earth, we might miss something completely different, which is essentially one of the main themes from the project Hail Mary. Here the idea was to explore life forms, like the astrophage, that seem to thrive on infrared light as opposed to optical light, or rocky, which refer to an alien that seems to breathe ammonia and also lives under crushing pressure. Now we actually do have some very similar extremophiles here on planet Earth, but they're normally in very small numbers and are only found in some super extreme conditions underneath the oceans. And so in the real world, scientists are now developing new frameworks in order to find life without knowing exactly what it looks like. Or basically, instead of just looking for example, water or oxygen, they're looking for a kind of a pattern of purpose. Or basically, they're looking for collections of chemicals in order to see if they can be produced by processes like metabolism or evolution. Or the other strategy, which is actually kind of interesting, involves measuring mineral diversity. And this, of course, applies to rocky planets. And that's because here on Earth, life spent billions of years creating and using minerals for habitats and protection, with our planet now containing over 6,000 known mineral species, with the vast majority actually being the result of life. In comparison, planets like Mars only seem to contain just over 160, though obviously there are some minerals that have still not been discovered. And so here this dramatic difference definitively suggests a diverse population of life on the surface that allowed for far more mineral-forming pathways compared to planets that are purely geological and don't contain biodiversity. But the entire list of these 45 planets is essentially summarized right here. And as you can see, only some of them are extremely Earth-like, but basically most of them seem to have at least some chance for possibly developing life. As I mentioned before, we've discussed most of these in some of the previous videos, but right now we don't actually have any definitive proof that life exists on any of them. These are just very promising targets. But this study only focuses on trying to find some kind of a bacterial or possibly primitive life, not some kind of an extraterrestrial intelligence. And that's because in our search for actual alien civilizations, also known as SETI or Search for Extraterrestrial Intelligence, the field is actually undergoing a major shift. And specifically a massive shift towards searching for technosignatures and focusing on specific scientific evidence of past or present technology. And one of the most exciting such discoveries was from back in February of 2023. Now we still haven't had any major follow-ups, but here there was an exciting detection of 8 possible technosignatures after scanning 820 stars, which involved a lot of data collected by the Green Bank telescope as part of the project Breakthrough Listen. But right now these are just 8 signals of interest that seem to have originated from directions of 5 different stars located between 30 to 90 light years away from us. All of these seem to be radio transmissions, but right now we don't really know what these transmissions were because so far they have not been redetected and technically could just be natural signals coming from some kind of a typical astronomical object such as a neutron star or some kind of a nebula. And so unless we detect them again, right now this doesn't really mean much. But apart from radio signals, a lot of SETI researchers have also started focusing on trying to find technosignatures in various atmospheres, and specifically by detecting emissions, or basically extraterrestrial pollution. For example, if we actually find nitrogen dioxide or chlorofluorocarbons in some kind of a distant planetary atmosphere, it could be a sign of an industrial civilization. Now once again, right now, nothing like this has been found anywhere, But detecting something like this would be an almost telltale sign that something really intriguing is going on, because we don't really know of natural processes that would form a lot of these chemicals. But despite all of these exciting developments, we're still faced with the famous Fermi paradox, the contradiction between the high probability for existence of life somewhere outside of our planet and the fact that we're just not seeing anything anywhere, even in our own solar system or any of the nearby stars. And though some scientists have been optimistic, saying that this great silence is just the result of our technology not being sensitive enough yet, and other scientists like the late Stephen Hawking warning us against trying to send signals out because it might be dangerous for us, quite a few scientists are now starting to think that maybe life is actually kind of rare, or possibly even almost impossible, because of some kind of a great filter that seems to prevent life from advancing or from continuing. We've actually discussed one of these concepts in a recent video you can find in the description. Nevertheless, even here in the solar system, there have been some exciting discoveries, such as for example hydrogen cyanide, discovered around the Saturn's moon Enceladus back in December of 2023. A chemical that's technically essential for life as we know it, which basically suggests that the oceans of Enceladus seem to contain a lot of necessary conditions for life to form. The question is, has it formed, and is there any life there? Now, we're not going to know any of this until we actually try to land there and try to collect some samples, and none of this is happening anytime soon. But having said all this, right now the overall scientific consensus, and something that I personally agree with, is that we basically have to exercise a lot of rigorous caution, or as the saying goes, extraordinary claims require extraordinary evidence. And so if some kind of a signal is detected, like it has been in the past, it will have to undergo years and years of rigorous confirmations before a formal announcement can be made. And so far, none of the previous signals, including the famous wow signal, managed to pass any of this. Even the famous wow signal has now been physically explained as a very specific type of an emission involving what seems to be some kind of a pulsar and some kind of a massive cloud of hydrogen. You can learn about this in one of the videos in the description, because scientists have now detected quite a few of these signals made in the same way. But the fact that this study has now identified 45 potential Hail Mary worlds, or basically worlds that are just the right size, contain just the right conditions, and receive just the right amount of energy, means that we're no longer just guessing, but instead are building a kind of a map. And so whether alien life turns out to be some kind of a sun-eating microbe or something even more strange, we might actually finally get some answers in the next few decades. Or maybe it just does not exist outside of planet Earth. And so on that note, we'll definitely discuss this more in some of the future videos. Until then, thank you for watching, subscribe, come back tomorrow to learn something else, support this channel on Patreon where you can find additional videos without any ads and can DM me directly, or by joining a channel membership that grants you early access. You can also support this channel by buying the 1 4% t-shirt in the description below. Stay wonderful, I'll see you tomorrow, and as always, bye bye.